Hey guys, in this video we will be going over slopes of a line and slope-intercept form. Okay, so if you haven't noticed, some lines are steeper than others. Some lines slant upwards to the right, some slant downwards to the right, and some lines are horizontal lines and vertical lines. We can put a measure to the steepness of these graphs, and this measure is called the slope. So the slope of a line measures its steepness, and it is given by the ratio of the vertical change in y to the horizontal change in x. And this is denoted by m. Let's explore this with an example. If we have a line going through points -2, -1, and 3, 2, to measure the slope m, we need to find the change in y over the change in x. We measure the vertical change from point to point, which is 3 units up, and then measuring the horizontal change, which is 5 units to the right. Therefore, our slope is 3/5. We can also calculate this by taking the difference in the y-coordinates over the difference in the x-coordinates. We say the line changes 3 units vertically for every 5 units horizontally. So the slope of a line containing the points x1, y1, and x2, y2 is given by the following equation, where x2 is not equal to x1. We also call the change in y our rise, and the change in x our run. So let's do an example. We want to determine the slope of the following line. So starting from this point, for the rise, we need to go down 3 units, and since we are going down, this value will be negative. And then for our run, we need to go to the right 5 units to get to the other point. And since we're going to the right, this value will be positive. Therefore, our slope is -3/5, which is the same as placing the negative symbol in front of the fraction. By the way, these fractions are all the same, where either the numerator is negative or the denominator is negative. If you didn't want to use the graph to find the slope, we could also use the formula for the slope. So let point 1 be -1, 2, and let point 2 be 4, -1. Plugging this into our formula, we get -1 minus 2 over 4 minus -1, which also simplifies to -3/5. By the way, it doesn't matter which point you choose as first or second. We could have made this point 1 and this point 2. We will still get the same slope either way. Okay, now let's go over slopes of horizontal and vertical lines. Recall that a vertical line is of this form, and a horizontal line is of this form. So for example 2, let's find the slope of the line containing the pair of points -1, 2, and 3, 2. Graphing this, we see that this is a horizontal line. Now, to find the slope, we can use the slope formula and plug in our 2 points. We can let this be point 1 and this be point 2. Simplifying, we end up with 0/4, which is just 0. Therefore, the slope is 0. So the slope will always be 0 for horizontal lines, and that's because this line has no steepness to it. Okay, now let's find the slope for these points. Graphing, we get a vertical line. And again, we can use the slope formula to find our slope. Plugging in our points, we get -5/0. And since we can't ever divide by 0, our slope is undefined. And the slope will always be undefined for vertical lines. Okay, let's now go over how we can find the slope of a line given its equation. So consider the equation y equals 3x minus 2. First, let's graph this equation. We need to find two ordered pairs that are solutions to this equation. Maybe we can choose 0 for x and solve for y, which is negative 2. And then choose 1 for x and solve for y, which is 1. We plot these points and draw a line going through them. Now, to find the slope of this line, we can use our slope formula and plug in our points. We get negative 2 minus 1 over 0 minus 1, which is negative 3 over negative 1, and this reduces to positive 3. So our slope for this equation is positive 3. Notice that our slope of 3 also appears in the equation. This is actually not a coincidence. Also notice that our y-intercept, which is 0, negative 2, also appears in the equation. This is also not a coincidence. So if a linear equation is in the form y equals mx plus b, which is solved for y, then the coefficient of x is the slope, m, and b is the y-intercept. So basically when an equation is written in this form, m is our slope, and b is our y-intercept. Let's apply this to an example. For example 3, we want to find the slope of the line negative 2x plus 3y equals 11. Now, we can actually find the slope without having to find 2 points and then using the slope formula. We can just get it in the form y equals mx plus b and easily locate our slope. So we need to first solve for y and get it in the form y equals mx plus b. So in order to get y by itself, let's start with getting rid of the minus 2x and add 2x to both sides. Then we divide both sides by 3, and we get y equals 11 over 3 plus 2x over 3, which is the same as y equals 11 over 3 plus 2/3 times x. Now we have the equation solved for y, so the slope is the coefficient in front of x, which is 2/3, and the y-intercept is 11 over 3. So when an equation is in slope-intercept form, y equals mx plus b, we can quickly recognize the y-intercept and the slope to graph the line. So for example 4, we want to graph the line using its slope and y-intercept. Again, notice that the equation is in slope-intercept form, and because it's in this form, we can easily identify our slope and the y-intercept. So we start with plotting the y-intercept at 0, negative 4. And using our slope, the rise is 3 and the run is 1. So from our point, we go up 3 units and then move to the right 1 unit. And this is where the next point will be located. And now we just draw a line through these points. And this is the graph of the equation. Okay, for the next example, since our equation is already in slope-intercept form, the y-intercept is negative 1 and the slope is negative 2/3. Since the slope is negative, we can either make the numerator or the denominator negative. Let's just make the numerator negative. So our rise is negative 2 and our run is positive 3. We first graph the y-intercept, and then from this point, we will go down 2 units, and then to the right 3 units. And this is where the next point will be located. And now we draw a line going through these points, and this is the graph of the equation. If instead we made the denominator negative, then from our y-intercept, we would go up 2 units, and then to the left 3 units. So either way, we would have gotten the same graph.